Hello again. Welcome back at Einstein Helps with Grade 10 Mathematics. This is the unit on algebra and we are doing lesson number 5. This lesson is on the product of monomials and polynomials. First we will look at the product of monomials or simple terms. Next we will look at the product of monomials and binomials, or monomials and trinomials. Next, we will look at the product of binomials. And finally, we'll look at some special cases. These are the square of a binomial and the multiplication of the sum times the difference of the same two terms. Let's first review the basic terminology. A product is a multiplication or the outcome of a multiplication. A monomial is a one-term expression, such as 2a, 3a squared, 12ab. Notice there is no plus sign in here. If there's a plus sign, such as in the expressions x squared plus 2x, or negative 3ab plus b squared. In such cases, they are binomials because each expression has two terms, which should be added up, but actually they can't because they are unlike terms. Since like terms can be combined, such as 3a and 12a, technically this is not a binomial, because we can simplify it by combining the two terms to create a monomial. The product of monomials is nothing new. This is basic algebra. We have already learned this. Here are some examples. 3 times a equals 3a. A times b equals ab. Negative 2 times a times b times b equals negative 2ab squared. 3a times negative 2b equals negative 6ab. So we will continue to the next item, monomial times polynomial, or actually monomial times binomial, and then monomial times trinomial. For example, 2 times a plus b. Note that the binomial must be written in brackets. 2 times a plus b. If there were no brackets, then it would say 2 times a plus b. And since we first have to do multiplication and then addition, this would equal to 2a plus b. But if we have 2 times a plus b, that means everything that is in the brackets, or like in the bag, must be doubled or multiplied by 2. 2 times a plus b is equal to 2 times a and 2 times b. So we get 2a plus 2b. Nothing else we can do because these are unlike terms. Also, negative 3a times brackets a minus b squared. So everything in the brackets, the a and the negative b squared, must be multiplied by negative 3a. Negative 3a times a equals negative 3a squared. Negative 3a times negative b squared is positive 3ab squared. Similarly, 2 times, in brackets, x squared minus 3x plus 1 is equal to, notice double everything in the brackets, so we get 2x squared minus 6x plus 2. So you may want to look at it in this way. The brackets form kind of like a bag, and whatever is in front of the brackets that you must multiply, this means that you have to multiply it for every item inside the bag. Every term inside the brackets must be multiplied by the factor or coefficient in front of the brackets. If there's nothing in front of the brackets, actually that's the same as having a 1 in front of the brackets. So if we only have a negative in front of the brackets, this is actually identical to negative 1 times whatever is in the brackets. If we have 2x in front of the brackets, means that every term inside the brackets must be multiplied by 2x. For instance, 2x times brackets 3x minus 2 is equal to 2x times 3x plus 2x times negative 2. 2x times 3x is 6x squared. 2x times negative 2 is negative 4x. Put them together, the answer is 6x squared minus 4x. Can you now do this question? Negative 3a times brackets 2a plus 4. Some people like to work with patterns of shapes rather than with patterns of numbers. So they can use algebra tiles. Green or blue reflect the positive and red refers to negative. There are two different lengths here. The short length stands for 1 and the longer length stands for x. Alright, so 1 by x by x, 1 by 1. Blue stands for positive and red stands for negative. The value of each shape is represented by its area or its relative area. This area is 1 by 1 is 1. This area is 1 by x is x. This area is x by x is x squared. Let's do an example. X times brackets 2x plus 1. We write the first factor at the top and the second factor to the left. The first factor is x, so it's positive, so I take an x shape, and that's all. And the second factor is 2x plus 1. 2x is x plus x, x plus x, 2x plus 1. So now I need also a 1 to put in there. Alright, so this picture represents our question, x times 2x plus 1. What is the result, or what is the product? Here is the result. We have x times 2x plus 1, and the answer is x squared plus x squared plus x, or in other words, 2x squared plus x. Next question, negative 3 times 2x minus 1. We start with negative 3 at the top. It's negative, so we need reds. So we got negative 1 plus negative 1 plus negative 1 makes negative 3. Okay, this is the question. The first factor is negative 3. There are 3 and they're negative because they're red. And 2x, they're blue, plus negative 1. Now we come to the answer. And here we have a combination of colors. And we have to note that negative times positive yields a negative answer. So here also negative. But negative times negative will yield a positive answer. So red and blue makes red. Red and blue makes red. Red and blue makes red. Negative 3 times negative 1. And as we said, negative times negative is positive. So we need 3 positive ones to fill in here. Negative 3 times 2x minus 1. And the answer is, each one of them is a negative x. So it's a negative 6x plus 3. Negative 6x plus 3. That's how we can use algebra tiles. If you don't want to go through the trouble and playing with little shapes that you cut out and so, you can also go to one step more theoretical by drawing a chart. So let's take a look at that. For the second question, we had negative 3 times 2x minus 1. Remember, 2x minus 1 is the same as 2x plus negative 1. So at the top, I write negative 3, and on the left-hand side, for the other factor, I write 2x, and underneath it, negative 1. So what is the product? First, we do negative 3 times 2x, and the answer is negative 6x. And then I do negative 3 times negative 1. Remember, negative times negative makes positive, so is plus 3. Next, we should look at the product of two binomials. As a general form, we can write this as a plus b in brackets times c plus d in brackets. Notice we have now a number of different combinations because we do a times c plus a times d, and then b times c plus b times d. Do you know the words term and factor? Take a look at this. What we do is we first multiply the first term of the first factor with the first term of the second factor. Then we add the product of the first term of the first factor with the second term of the second factor plus the second term of the first factor times the first term of the second factor plus the second term of the first factor times the second term of the second factor. Now, that's pretty tricky to remember it like that. Unless you really know your terminology, then you can do this. But we have found a shorter form, and we use FOIL, F-O-I-L. This is a trick you can use. F stands for first, so it's a product of the first terms. O stands for outside, so it's the product of the outside terms. I stands for inside, so it's the product of the inside terms. And finally, L stands for last, so it's the product of the last two terms. So, let's look at some examples. The first question was x plus 2 times x plus 5. Note that we have as the first factor x plus 2 and the second factor x plus 1, 2, 3, 4, 5. And here we have the answer. The product of x plus 2 times x plus 5 is 1x squared, and 1, 2, 3, 4, 5, 6, 7 x's. 2 plus 2x plus 5x is 7x. And then we got 2, 4, 6, 8, 10. So x squared plus 7x plus 10. And for the second question, we have the first factor is x plus 3, and the second factor was 2x plus 4. And lining up the gaps vertically and horizontally, we'll get this answer. 2x squared plus 6x plus 4x plus 12. In other words, x plus 3 times 2x plus 4 gives as answer 2x squared plus 10x plus 12. Now we've come to the last section of this instructional video. We are still exploring the product of binomials, but now we look at two special forms of it. First, a binomial squared. In general terms, a plus b in brackets squared, or a minus b in brackets squared. And the second special product of binomials is a plus b in brackets times a take away b in brackets. In other words, the sum of two terms multiplied by the difference of the same terms. A plus b times a minus b. First then, binomials squared. First example, x plus 3 squared. Let's first look at the algebra tiles. Notice the first factor is x plus 3. The second factor is the same, x plus 3. X plus 3 squared is the same as x plus 3 times x plus 3. Now look at the result. The first term was x, and the first result is x squared. The second term was 3, and part of the result is 3 squared, or 9. But now the outside product and the inside product of the terms. Notice that they're both the same, 3x for outside and 3x for inside. So we can summarize the result like this. A plus b squared is always a squared plus the double product of the terms, 2 times 3x, plus the last term squared. In this case, x plus 3 squared is equal to x squared plus 6x plus 9. The second example of a binomial squared, 3x minus 1 squared. So notice 3x minus 1 squared is first term squared. 3x times 3x is 9x squared, plus the double product of the terms. The product of 3x and negative 1 is negative 3x. Double that and you get negative 6x. And the last term squared, negative 1 times negative 1 makes now positive 1. The answer then, 9x squared minus 6x plus 1. And here is an example of the second special product. Notice that we have as first factor 2x plus 1, and as second factor 2x minus 1. Remember, red stands for negative terms. So the result is, again, first term squared. 2x times 2x is 4x squared. But the rest is different. Let's take a look at the second squared. Because we have first a plus 1 and here a negative 1, the product of the last terms will be negative 1. But Now the interesting part comes for the middle products. We've got the outside terms and the inside terms. So we have 2x and negative 2x. And they, of course, cancel each other out, because 2x take away 2x leaves us with nothing. So the end result really is 4x squared minus 1. Or in other words, first term squared minus second term squared. So the general rule is a plus b times a minus b yields a squared minus b squared. Now finally, one more example of the second special product. In other words, sum times difference of the same two terms. X plus 4 times negative x plus 4. Now notice that the negative is actually in the first term, so we have to rewrite it to recognize it as a sum times a difference. So we can switch the two terms in both binomials to get 4 plus x times 4 minus x. When we work this out, the answer should be first term squared take away second term squared. The first term is now 4. 4 squared is 16. The second term is x, so is 16 minus x squared. Or if you want to, minus x squared plus 16. In this lesson, we have looked at multiplication of algebraic expressions. We started with the product of monomials. We went to monomial times polynomial. Then we looked at the product of two binomials. And then finally we looked at the special products of two binomials. Make sure you practice this a lot. And I would say review this video. Make sure you really get a good grip on this material, because if you don't, you will have problem with the next lesson. Next lesson, lesson 6, will be the last of the topic on algebra and number sense. In this, we will look at factoring. Notice that in lesson 5, we did multiplication. In other words, we started with a multiplication and ended up with a polynomial. In lesson 6, we will do the opposite. We will start with a polynomial and see how we can rewrite it in the form of a multiplication. Anyway, keep up the good practice, check your answers, and don't go on to lesson 6 until you really understand multiplication of algebraic expressions. Good luck.